Hello everybody, how are you people? Am I audible to each and every one of you? Just tell me how many of you are here. Okay, so we are back again with a very new episode of our strategy sessions. You all must be knowing about these strategy sessions wherein we are discussing previous year very important questions and the questions where most of the students have faced difficulty, and this has been running from past so many months. So welcome back. I am back again with a very new session, and today's topic is obviously mechanical properties of solids and liquids, so which actually inculcates fluid mechanics, fluids at rest, and all those stress strain questions of mechanical properties of solids. So we'll be dealing questions based on all these things, and I'll just summarize you up wherein I'll be telling you the topics which are mostly asked and questions based on those topics are most frequently asked in JEE Main or JEE Advanced. If I talk about the previous year records, then around 2 to 3 questions have been asked from this topic, so this topic becomes a very important one. And moreover, the concepts of fluid mechanics, as I told you, mechanics concepts are used so widely throughout your 11th and 12th. So over here as well, some concepts of fluid mechanics you can expect to be over there in electrostats, wherein two charges are there inside water and forces of electrostatic and buoyancy are also present. So things of that sort, mixture of concepts questions you can expect. Okay, so this will be the start of the session. Just tell me how many of you are here. Hi Rahul, hi Kalpana, hi Aditya, hi Raktim. I think you all are very fine now. So let's start. Let's just give a discussion about what strategy sessions are. So you all must have been noticing, और जिन्होंने नहीं notice किया है इन sessions को, आप subscribe करिए channel को जिससे आपको regular updates मिलते रहें. Okay, JEE YouTube का Extramarks का जो channel है उसे subscribe करिए, और इस पे इक्वली आपके क्रैश कोर्स के सेशंस भी हो रहे हैं डेली 5 PM. देन उसके बाद यहाँ पे वेबिनार्स भी हो रहे हैं. देन देर आर सो मेनी ऑफरिंग्स फॉर यू गाइज. देर आर वेरी गुड क्वालिटी शॉर्ट्स, वेरी गुड क्वालिटी एपिसोड्स एज वेल, वेर इन कॉन्सेप्ट वीडियोज़ आपको बहुत ही अच्छी तरीके से समझाए जाएंगे. सो इफ़ यू हैवेंट सब्सक्राइब्ड इट येट, you are missing something guys, seriously. Just subscribe it right away for getting regular updates. And about the strategy sessions, so we are obviously discussing previous year top notch quality questions of JEE Main and Advanced, wherein most of the students have faced difficulty. Okay, then after that question solve करा रहे हैं हम, but apart from that we are giving some very good strategies as well, जिससे कि whenever you face such kind of a question, then what should be your approach towards that question. कैसे उन सब questions को approach किया जाए, कैसे गलतियों का जो एक element होता है उसको decrease किया जाए, and we'll be obviously providing you an error quotient as well, that is यहाँ पे students ने कहाँ गलती की and what you should not do. All the do's and don'ts we'll be discussing about all of them in great detail. And with this, let's just talk about myself. My name is Adarsh Rai and I'm a graduate from NIT Bhopal. I myself have cleared this exam, and actually I know after this much of experience as well what all key features you should have such that you can actually ace this exam. This exam is not that tough. It's just the right approach which you should have with right guidance and right type of knowledge and practice obviously. So the mixture of all these things can actually help you crack this exam, and this is not a very big deal even. Okay, so but the right approach is very important. You should always have a very right approach, the guided path. You should not travel on any other path, because there have been students who were very good, but just because the guide was wrong or the path taken by them was wrong, they were not able to clear this exam. So be very careful with that. And if I talk about Extramarks, so Extramarks has a very good record among JEE NEET segment, that we have actually made sure that 1 out of every 7 candidate has been selected in JEE Main and is presently selected in one of the colleges. Okay, and here over here, what all content, I'll be just giving you a glimpse about our application as well, Extramarks the learning app. So the content over there in the app has been specially curated by experts JEE faculties. Okay, and they themselves have cleared this exam. It's a very good set of IITians and NITians we have over here, and they have actually sat down and discussed so many things, what all topics have been asked most frequently and what all type of questions. So basically the test series and the tests which you can actually find in the app, they have been specially curated to cater to the present day needs. They are not outdated, right? The modern type of questions which are frequently asked by NTA, the question pattern have been made in sync with that only. So do download it if you haven't done it. previously and avail the benefits. They are seriously very good for anybody's preparation. So these will be the topics today, and actually these are the topics in this bigger chapter, mechanical properties of solids and liquids, wherein most of the questions has been asked from past few years. So it's obviously surface tension, it has been a hot topic, and modulus of elasticity, whether I talk about Young's modulus, Welk modulus, or shear modulus. Then pressure in static fluids, a very easy one, but cases have been created in such a fashion that there's a question also, that force on a wall and so many others like that. Then buoyant force, obviously curvature of surface, and if a fluid is at rest or is in acceleration mode, then how the curvature changes, or if it is rotated, then what will be the effect on curvature of surfaces of fluids. So these things also will be discussed, and obviously terminal velocity, you all must be knowing about terminal velocity as well. Okay सर, क्या अब JEE 2022 पॉसिबल है? बैकलॉग काफ़ी है. बिल्कुल पॉसिबल है अभय, सही तरीके से आप करोगे तो एनीथिंग इज़ पॉसिबल. Good evening teacher. Okay, K47, your name is very good. Okay, now let's move ahead and talk about discuss this question of JEE Main 2021. So what this question is, the normal density of a material given to us is rho. Okay, its bulk modulus of elasticity is also given to us, it is as K, and magnitude of increase in density of the material when pressure P is applied uniformly on all its sides. So because of the presence of pressure, obviously its volume will decrease. Okay, so what we need to find? We need to find the magnitude of increase in the density. Now obviously mass is remaining constant यार, देखो mass is not changing, so mass is not changing but volume is decreasing. So in turn what we can say is pressure will, sorry not pressure, density will increase, and this is what they're talking about, the magnitude of increase in the density of the material. That means we need to find the value of delta rho. Okay, so what will be the approach over here? First of all, what is density? So density is m by v. Okay, yes sir, perfectly. Now if I am about to use those concepts of error analysis, so if you clearly remember, then I can write this delta rho by rho is equal to, m is not changing, m is constant, so this can be written as delta v by v, right? But if I am talking about error, then this is the expression, but if I am talking in normal sense, then there will be a minus sign, just suggesting that if delta v is increasing, then delta rho will decrease. Okay, and if delta rho is increasing, then delta v will decrease. Okay, cool enough sir, perfect. Now this expression can be derived from over here, and then we very well know what is the expression of bulk modulus of elasticity. So bulk modulus of elasticity goes by this relation, so it is bulk stress upon bulk strain. And what is bulk stress? So magnitude of increase in density when a pressure P is applied. So bulk stress is obviously the pressure which is applied from all the sides, the pressure which is applied from all the sides, and because of the application of pressure, the volume decreases. Okay, it gets compressed. So delta V by V is the bulk strain which will be developed, and obviously there is a minus sign just to represent that there will be a decrement in the volume. Because of the pressure, the volume will decrease, and obviously delta V will have a negative value. So to make the value of K as positive, we provide an extra negative sign in this expression. Okay, so you can actually relate things from here. Okay, delta rho by rho can be replaced just over here to be delta V by V, and I can easily calculate the value of delta rho from here. So what happens is, if I just replace this value of delta rho by rho over there, so K will even turn out to be P upon delta rho by rho. Rho will go upstairs and delta rho can come over here, and P rho will remain over there. So delta rho will equal to P rho by K. So is this the answer? Yes, it is the answer. Now what happened with this question? Well, it's a pretty simple one, right? With the explanation part, you can actually feel it's such a simple question. In 3 or 4 lines I was able to find the result. But what happened with this was the people were not able to comprehend what this question is actually saying. Okay, the question was meant to play with actually the level of thinking, what he can actually perceive. If some amount of condition has been mentioned, so actually can you decode that condition, or can you just extract those data from that particular question? So it was all about that. And trust me, the best part to gain that ability or to develop that ability to actually decode a question can only be decoded by you only, and it can only be decoded by practicing more and more questions. So I have been practicing this question, so it was very easy for me to finally come at a result, and even you can do that. You don't have to practice that many questions which I have done, but you can practice so many questions, and depending on the type and variety of questions. So don't ever try and practice the same type of question again and again. Just practicing y is equal to stress upon strain will not ever help you. You need to diversify. You need to diversify the approach and the type of questions which you are practicing, and in doing so, what you will develop is, you will develop that ability wherein you can decode a question if you haven't heard of it any time. Okay, so this is the ability which I was talking about, and that actually created a trouble for students, and they were not able to find the right answer. So here is the right answer, and I suppose you liked it. If you're liking this lecture, hit the like button, subscribe it, and share it with your friends, because most of your friends must be in need of these lectures. Okay, now let's move ahead and talk about another question, and this was asked in JEE Main 2021 itself. There have been so many sessions in 2021 and 2020, so you might find so many relevant questions. You might find so many previous year question series from these 2 to 3 years only. Okay, so the length of metallic wire is L1 when tension in it is T1. Okay, so there's a metallic wire, its length is L1, and the tension developed in it is T1. Okay, perfectly fine, sir. It is L2 when the tension is T2. So if the tension is changed, increased or decreased, whatever it has been done, if the tension is decreased or increased, but the tension now changes to T2 and the length also changes, it becomes L2. Okay, the original length of the wire will be. Now just tell me how tension can be developed in a wire. So if there is a wire, if I just pull it from this end, suppose I am pulling it from this end with a force F, will tension develop in it? No, obviously not. Why? I will have to either hinge it with a rigid support over here, or instead what I can do is I can apply the same amount of force from this end as well. Okay, and in both these cases a tension will develop. So actually this is the case, right, when we talk about stress. So because of the tension, what the approach over here should be, that because of the tension developed in the string, it has been pulled from both the ends with the same amount of force, and that is obviously equivalent to T1 when I am talking about the length L1, and it is obviously equal to T2 when I am talking about the length L2. Okay, so because of this tension there might be some change in the length. Obviously there might be some change in the length with respect to its original length, and what we need to find, we need to find the original length of the wire only. Okay, so our approach will be pretty simple. So what we'll do is we'll use that formula. Okay, what formula? I'll be using this formula, that stress upon strain is equal to y, since I am talking about longitudinal stress, right? So longitudinal stress, that means Young's modulus of elasticity will come into picture. So stress, what is stress? So in the first case the stress will be T1 upon, they are not mentioning anything about area, right? So if they are not mentioning anything about area, see, in a normal sense what should occur? If length is increasing, the area should decrease, and if length is decreasing, then area should increase. But they are not at all mentioning anything about area, so why to get into trouble and call for it? We'll consider the area to be constant. We'll not at all consider the change in area. Okay, so T1 upon area will actually give you the value of stress. Perfect. And strain will be change in length upon original length. So what is change in length? So change in length can be represented as delta L1 in case of first one, divided by, I don't know the original length, so I'll just mention it to be L0 or L, any length, and this will be equal to y. Clear? Perfectly clear, sir. Can I replace it like this, that T1 will be equal to, okay, not like this, not like this. What I'll do is, I'll just replace this delta L1, I'll just put this delta L1 somewhere on RHS and RHS individually, and rest other terms on the other side. So delta L1 can be represented as L1, which is the length right now, minus L0. Clear? Exactly clear. Because delta L is what? The change in length. So change in length from its original length. So L1 minus L0 will actually result in delta L1. So delta L1 can come over here, and the rest of the terms can be over here. So L1 minus L0, this L0 will go upstairs. So T1 L0 divided by y into A. This will be value of L1 minus L0 equals to T1 L0 by YA. Okay, sir. On a similar stance, what I can do is, I can do the same thing over here in case of T2 as well. So T2 upon A will be equal to delta L2 times L0. So over there also this kind of an equation will come. L2 minus L0 will be equal to T2 into L0 divided by y into A. Perfect, perfect. Yes sir, एकदम perfect. कोई इशू है तो बताओ मुझे आप चैट में जल्दी के जल्दी. So ये रिलेशन यहाँ पे भी हो जाएगा, ये रिलेशन यहाँ पे हो जाएगा. Now the next step is just divide them. Just divide them and you'll get the result. And what happens when we just divide them is this YA L0 will get cancelled, and finally what you will be remaining up with is that L2 minus L naught divided by L1 minus L naught will be equal to T2 upon T1. Yes sir, perfect, एकदम perfect. Now what we need to do, we need to multiply, cross multiply करना है, यहाँ T1 multiply करेंगे, यहाँ T2 multiply करेंगे, and we can get the final result. So over here on multiplying T1 with it, what expression we'll get is T1 L2 minus T1 L naught. So T1 L2 minus T1 L naught, and this will be equal to, यहाँ पे T2 multiply करो, so T2 L1 minus T2 L naught. So T2 L1 minus T2 L naught. Clear? Yes sir, perfectly clear. अब मुझे क्या निकालना, मुझे L naught निकालना था, right? So put T2 over here, put T1 over here, you will get L naught into T2 minus T1. This will be equal to T2 L1 minus T1 L2, और इस T2 minus T1 को यहाँ नीचे लाना है, so you will get the final expression as T2 L1 minus T1 L2 divided by T2 minus T1. It was more of mathematics into it, right? So the entire physics was just restricted to this equation. If you were very capable to deduce this relation from this result, then the rest part was on entirely mathematics. So you need to be strong in mathematics, because without maths is the language of physics. So you need to be very clear with mathematics while multiplying. So there occurs an element of error while doing this multiplication as well. So meanwhile, trust me, even I was practicing or solving this question. There occurred an incident where I just confused it with T1 was up and T2 was down. So you need to be very careful with these things. Such kind of error can actually be very, very bad for you, because you'll feel that you'll be getting the right answer, in spite of that going for the wrong answer, and there obviously will be a wrong answer as well. So the question maker will obviously count that thing also, that the student can do an error wherein T1 will be over here and T2 will be over here, and he'll represent an answer something like that. So those things should be very carefully taken up with, and those silly mistakes should be avoided. What I used to did when I was a student was, I always kept at the back of my mind a very clear picture that I possess the ability to do a silly mistake. So whenever I used to solve a paper, any test series, so I will definitely, my subconscious will always tell me, be very careful, because there can be a possibility that you can do some silly mistake. So that portion of mine always used to work, and it actually got resolved. But this was my approach. You can obviously follow that, and you might have your own as well, but you should always focus on these things as well. These silly mistakes can actually be very, very bad sometimes. Okay, so this is the final result. Do we have an option? Yes, we have an option, and we are absolutely correct. Okay, so let's move ahead and talk about the next question, and the next question is very simple. So what it says is, a cylindrical vessel containing a liquid is rotated about its axis. So here is the axis, it is being rotated. Okay, so that the liquid rises at its side as shown in the figure. The radius of the vessel is 5 cm and the angular speed of rotation is omega radian per second. The difference in the height h of liquid at the center of the vessel and side of the walls is, and it's a very common result. Okay, so many of you must have been doing it from your childhood days as well. When do you ever imagine creating a drink of rasna, or any in summers, creating any drink with using some mixers? So what you used to do, you must have always swirled your spoon over it. So what you must have observed was that inside this glass container, this kind of structure was created. Basically it was because you were continuously moving your hand in a rotatory fashion, or moving your spoon in a rotatory fashion, and this kind of a structure or surface of the liquid was getting created. So the reason for that was obviously the rotation of the water molecules. So what happens in the case when water molecules are rotated, that there occurs a pressure change because of the acceleration of the fluids. Obviously when anybody or any object is in motion, in circular motion, there will always be an accelerated motion, right? There will be an acceleration towards the center, and water has to go through that. So there occurs an acceleration along the center, and inside this liquid there occurs a centrifugal kind of an acceleration. So what happens? Pressure increases as we move towards the outer edges. Okay, so the pressure over here and the pressure over here, unlike the case when the liquid was just at rest, it was equal to, they were same, right? But now since there is an acceleration, centrifugal acceleration with the water molecules, they will have a pressure increment towards outside, and this is the reason why the surface curvature is being created. Okay, because the surface curvature always has to be perpendicular to the net acceleration. So obviously there is a G over here, and there is a acceleration because of your movement of your rotatory motion. So the net acceleration will somewhat like this, and obviously this the tangent, the portion, it should be the surface should be perpendicular to your net acceleration, and this is the case why this kind of a structure is being created. Now we need to find what over here. We understood the concept why it is occurring. So what we need to find is, we need to find the value of this h. Okay, we need to find the value of this h. So how this h can be understood? So I'm going to give you a very good expression. Okay, so what happens is, this h height, let me represent it as y. So this y will always be equal to omega square x square upon 2g, wherein x is actually the distance from the center. Okay, so if you can just remember this expression, then you can very well find the result in one stroke only. Just replace the value of x, that is equal to 5 centimeter. So it will be omega square 25 upon 2g. And how this expression came was, it was very simple, that here the pressure is P naught, and also here the pressure is P naught, and at this point let's say pressure is P. Okay, clear? Because these two surfaces are open to air, so the pressure will be P naught, and over here we are considering a pressure P. So pressure is increasing as we move towards the wall as well, pressure is increasing as we move downward as well. So P and P naught, we can find two relations over here. And what will be the two relations? The first relation will be P will be equal to P naught minus rho GH, right, this distance, and for the time being let's consider this distance to be equivalent to y. Okay, and if I talk about this radial thing along the radius, what will be the pressure change? So over here what happens is, we need to consider some small elements of water molecules. Reason is because every water molecules, as we move farther and farther away from the center, the acceleration, the centripetal acceleration value will increase, because it's obviously omega square r. So the more you are distant away from the center, more will be your acceleration. So we need to use calculus, and on using calculus, what I can finally deduce is that the relation will come somewhat like this. P will be equal to P naught minus omega square x square by 2, and there will be a rho as well. Okay, omega square x square by 2, am I right? Yes sir, you are right. Okay, so this will be the expression. This will be the expression that on using calculus, that can be derived very easily, not a big deal. So this will be the pressure change along the radius. Okay, and on just equating both of them, what you will finally get is that the value of y in terms of x will come somewhat like this. So y will be equal to omega square x square by 2g. So remembering this result can actually help you with whatever is the radius in some other case, or now whatever is the height. They can be anything. You just remember this expression, and whenever such kind of a question of the curvature behaving like a curved pattern because of the rotation, you can very nicely find the value of y, x, whatever is given in front of you. Okay, so over here also we will be using the same result. So x is what? X is 5 centimeter, just replace it over here, and here you get the final answer, that is 25 omega square by 2g. Clear? It was a pretty simple and easy one. Okay, if you face any difficulty, just remember this expression, and I even told you how this expression came. You just need to equate them and you'll get this expression, and using them you can very well easily find out the real answer. Okay, and just remember this expression, because there is one more question which I want to discuss in front of you, and there I'll be using this equation. Okay, now let's move ahead and talk about a different question of 2020. So the reason this question has been placed, because it's about approximation, and there are asked so many questions nowadays wherein the maker is actually checking, are you capable enough to approximate values? How much you are into that exact multiplication and division. So there isn't any time left for you so that you can multiply 432 into 648. You just need to ease up your all multiplication time which you are spending, right? So this question I have definitely put up for that purpose only. So what this question says is, let's understand it. First let's understand the question, what this question is all about. So it says that an air bubble of radius 1 centimeter in water, okay, has an upward acceleration of 9.8 centimeter per second square. So be very specific that the acceleration is 9.8. 9.8 meter per second square is acceleration due to gravity, but that is in meter per second square. In centimeter per second square they have given the acceleration. Okay, fine. The density of water is 1 gram per centimeter cube. That's pretty normal, I know that. and it is 1000 kg per meter cube when I turn it in kg per meter cube, and water offers negligible drag force on the bubble. So what this drag force is all about? It's about the viscous force. So there isn't any viscous force acting on the air bubble. So what is the force acting on the air bubble? The force will be buoyant force. There will be an action of buoyant force, and because of that only, buoyant force will definitely be greater than mg, and this is the reason why the air bubble is accelerating in upward direction. That's pretty simple. So then the mass of the bubble is, we need to determine what is the value of mass. Okay, now let's solve this case. So what is happening is, this is an air bubble, and obviously its density is very less, obviously, but we don't need to consider its density because we need to calculate its mass, and I can very well do that. Just wait for a while. So what happens is, on this air bubble, two forces will be in action. One will be mg because of its own weight, and the other one will be rho vg, and that is because of the volume of liquid which it has displaced. Okay, so the volume of liquid, the volume of this air bubble which is inside liquid. So this is an air bubble, it's obviously inside a liquid, so the entire volume is V. Rho is obviously the density of the liquid which is present around it, okay, and G you very well know. So this rho Vg is obviously greater than mg, and by how much amount it is greater? It is in that amount such that it is providing an acceleration of 9.8 centimeter per second square. Okay, and this is the case, right? The air bubble is moving in upward direction, and obviously the motion must have been because of rho Vg. Rho Vg must have been greater than mg, and this is the reason it is accelerating. So the equation is pretty simple, right? We just need to calculate the value of m, and there goes the tricky element because the values aren't very nice given to us. It's 9.8, 98 and so many things. So let's first do one thing, let's just eliminate m over here. So m will be equal to a plus g, and this will obviously be equal to rho Vg. So what we need to do next is replace a plus g over here and just calculate the values. So what will be the next value? Just let's do one thing. So m is turning out to be rho Vg upon a plus g. Okay sir, perfect. Now what is the value of rho? So obviously entire entities we need to consider in terms of gram and centimeters cube only. So CGS unit will be using because entire things have been given in CGS only. So what is the value of rho in terms of gram per centimeter cube? It's 1 gram per centimeter cube. The value of volume, so what is volume? We have been given with the value of radius, so it will obviously be 4 by 3 pi r cube, that is 1 centimeter whole cube. Perfect sir. Then G, what is acceleration due to gravity? So they were very helpful in giving us this value as well, and this is equal to 980 centimeter per second square. Okay, perfect. Then what about a plus g? So a plus g will be 9.8 into 980. So now what you are going to do? Will you add it up and then the value will be 989.8 and divide 980 by 989.8? This is a huge task, and then multiplying it with 4 by 3 pi. So can you do that? Obviously you won't be doing it. So what is the approach over here of approximation is that here the value, the numerator is pretty lesser than what the denominator is, because it will be 989.8 something and it will be 980 only. But here the pi value is 3.14. So what I can do is I can consider this value of pi to be near about 3, and in just reducing this numerator I can also reduce this element of denominator 9.8. Okay, and then this 980 can be easily removed with this 980, and since I have considered this pi to be nearly equal to 3, so I can just remove this. So the value, my final answer will be a value which will be very close to 4. So which one amongst the option was very close to 4? Just tell me. So this has a huge difference, this also has a huge difference, this can never be. So the entire result is 4.15 gram. Are you getting my point? How I actually did? Matlab, it was a pretty normal and a simple case. मैंने एक line एक equation में I haven't multiplied or divided even. It was just the usage of brain कि मैंने यहाँ पे 3.14 को entire थोड़ा सा कम करके 3 consider किया, तो यहाँ पे भी मैंने denominator को थोड़ा सा कम कर लिया. Obviously अगर आप बोलोगे सर यहाँ पे 9.8 कर रहे हो, वहाँ 0.14 कर रहे हो, या take the decimal boss, take the decimal. इसको आप ले लो 9.8 ले लो, यहाँ भी 9.8 ले लो और इसको और कम कर लो यहाँ का 2 डेसिमल यहाँ पे कर दो तो 0.098 हो जाएगा. सो ये डेसिमल यू कैन डू दैट. एक आप इक्वल रेशियो प्रोपोर्शन के केस में डिक्रीज कर रहे हो. सो यहाँ पे इसको कम करने से 980 से आपने कैंसिल कर दिया, वैल्यू नियर अबाउट 3 होगी. 3 से 3 कैंसिल. सो 4 के आसपास ही हमारी वैल्यू आएगी. एंड 4 के आसपास हमारी वैल्यू ये रही 4.15 ग्राम. So using this method you can actually find the result. You don't need to multiply each and every time. It will actually create a lot of trouble. Chances of doing error can also occur, and also there can occur a possibility that a lot of your time has been used up and then you have finally found the right result, but what is the sense in solving a question in 10 minutes over there when only 3 hours are given to you. So these kind of questions can be solved at the piece of your house where you have entire amount of time. You can take 1 hour to do that multiplication. You can also use a calculator, but that's of no use, right? Because we need to go for that examination. We need to solve the questions in a span of just 3 hours, okay, and that too all the 3 subjects. Okay, so do learn these things, try and understand these concepts of approximation and how they can actually ease out your calculations, and you can very well find such kind of questions in our app as well. Okay, so you can find the link to the app in the description. You can download it and actually practice so many questions based on that. You will definitely get. So do practice them. It will actually develop that skill of yours and save a lot of amount of time. So Raktim is asking, what probability of questions getting repeated in JEE 2022? Questions getting repeated in JEE 22. So I am again repeating myself. I have discussed this thing in the previous episodes as well, that questions will not repeat. The concepts can repeat. Okay, the values will obviously change. The values of change here, 5 can be replaced by 7. Here only 1 structure can be there or 3 structures can be created. So the concept behind this question will remain same. That can be repeated, it has been repeated, but the values might change. The values might change from one time to another. There is a very less probability that the entire question gets repeated. Okay. So now let's move ahead and talk about this question asked in 2020 as well. So a very beautiful question. If you have actually studied what is the reason behind the width of the walls of a dam getting increased as we move down and down and down. So what happens is, you all if you have ever went to a dam, you all must have. So the walls, basically the walls of the dam are made somewhat like this. Okay, so at the lower ends the wall is pretty wide, and the reason to this is the excessive amount of pressure it has to handle, and this is the reason why it is wide. So this question is somewhat like that only. Okay, so we'll be using it, we'll be actually deriving the result. Okay, so don't worry about that. If you haven't been memorizing the fact of the force on the walls of a dam, we'll be just deriving it. It's not a very big derivation as well. So what happens is, what they're saying is, two liquid columns of same height 5 meter and density is rho and 2 rho. So one of the density is rho, other one is 2 rho, are filled in a container of uniform cross sectional area. The ratio of force exerted by the liquids on the upper half of the wall is to the force exerted on the lower half of the wall. So we actually need to calculate this force, and we need to calculate the force on the lower half as well, and we need to find the ratio of them and specify the ratio. So options have been given to us. So let's calculate it, let's understand it, how to do it. So what I'll be doing is, let's say suppose here is liquid, here's the liquid over here. Okay, so the density of the liquid is rho obviously, and what will happen is, as we move deeper and deeper, the pressure increases. So there is not a similar amount of pressure exerted on these walls. At the topmost edges the pressure will be less, and as we move towards the depths the pressure will be more, and because the pressure is more, so the force will be more. So now every element, if I can actually categorize them into different elements, so on different element a different amount of force will occur. So on the elements which are on the upper side will obviously experience a lesser amount of force as compared to the elements, small elements on the downer side. So then obviously we need to use calculus over here. So how I can do is, I can actually consider that when I am at a depth of y, I can consider an element which is of length dl. Yes, right sir, perfect. So the pressure experienced on this small dl element will obviously what will be, so here the pressure they were very helpful, and they gave us the pressure at the top surface to be 0, or else if it was open to air, then an element of P atmosphere would have come into picture. So here the pressure has been stated as 0. So what will be the pressure over here? The pressure will be over here will be rho gy. So rho gy, because of rho gy, there will be a force acting on this small element dy, and that will be equal to rho gy into what is the area? Now what is the area? Sir, only length has been mentioned. So this is the length, and obviously it will be a wall, right? It will be a wall like this. So this is the length, this is the length, okay, this is the length. I can term it to be L. So rho gy into L into dy. This will be the very small dA area. Okay, this will be the very small dA area which I am just shading over here. Are you getting my point? So length times this small element dy will actually give you the value of dA. So this will be the expression of very small amount of dF force. Okay sir, we understood this force. Now what we need to do, we need to integrate it up. So we need to integrate it up. So dF is coming out to be rho gy into L dy, and we obviously, when we are at a length y over here, okay. So we need to integrate it, we obviously need to integrate it, and the integration will be from 0 to 5 meter. Yes, absolutely sir. And over here it will be a net cumulative force, so there is no need to put limits over here. So this will amount to the net cumulative force, and rho g and L will obviously come outside because they are constant, and y dy is y square by 2. So it will come out to be rho gl into y square by 2, that will be 5 square by 2. This is the answer for force experienced by the upper half of this wall. Okay sir, let's mention it to be F1. Perfect, perfectly cool. Now if I talk about the lower half, so it is specifically mentioned to us that the density over here was rho and the density over here is 2 rho. Okay, so now what will be the force? So the force will be, let's calculate the pressure, right? So now let's change this thing and consider this y not from the top, from this point, okay, from this point. So this is our y now, okay, and on this small element what will be the pressure now? So what will be the value of pressure? So the pressure will be because of this entire upper side of water column as well, and because of the water column till the length y has achieved. So what will be the pressure because of this entire column? So over here the pressure was 0, over here the pressure will be rho g5, rho gy, whatever is the length, rho gh. So here it will be P will be equal to rho into g into 5, plus over here it will be 2 rho, because the density has now changed to 2 rho into g into y. So I'll just tell you, so the pressure over here, so if I am talking about dF2, right, so dF2 will be the pressure at point 2 into dA. Okay, the pressure acting at point 2 into dA. So what is the pressure acting at point 2? It will be equal to obviously 0 plus rho into g into 5 plus 2 rho into g into y and whole multiplied by dA. Now what will be dA? dA will again be the same thing what we have just written. So this will obviously be a wall like this. So this value is dA. So it will be dy into L. This is the value of what? dA, the small area element of this entire shaded region. Okay, the force will be applied on that small area. Now again what we can do, we just need to integrate it. So dF2 will obviously be equal to rho g5, just provide all these elements to each and every term. So rho g5 into L into dy, it will be rho g5 into L into dy, integration from 0 to 5. Perfect sir. Then the next term will be 2 rho gy into L dy. So 2 rho gy into L gy. 2 rho g into L, 2 rho g into L. Okay, so 2 rho g into L into y dy, and इसका भी इंटीग्रेशन 0 से 5 तक होगा. Perfect sir, perfect, perfect, एकदम सही लिखा है ना? Yes, एकदम सही लिखा है. Now what we need to do, we need to integrate them. इसका इंटीग्रेशन करेंगे तो इसका इंटीग्रेशन y आ जाएगा, लिमिट्स डालना है 5 से 0 तक, इसका इंटीग्रेशन आ जाएगा y स्क्वायर बाय 2, लिमिट्स डालना है 0 से 5 तक, और फिर हम फाइनली आंसर निकाल देंगे और रेशियो निकाल देंगे यार. इसका इंटीग्रेशन कितना आ जाएगा? F2 आ जाएगा. सो जल्दी F2 की वैल्यू बताते हैं. तो F2 की वैल्यू कितनी आ जाएगी? यहाँ पे आ जाएगा भाई रो g5, तो 5 रो gl इंटू dy, y हो जाएगा तो एक और 5 आ जाएगा, प्लस यहाँ पे कितना आ जाएगा? 2 रो gl इंटू वाई स्क्वायर बाय 2, यानी 5 स्क्वायर बाय 2. ठीक है, सही है सर, एकदम परफेक्ट. ये 2 से 2 कैंसिल हो जाएगा, तो ये एंटायर टर्म कितना हो रहा है? ये हो जा रहा है, ये 5 स्क्वायर हो जाएगा, 5 इंटू 5, और यहाँ भी 5 स्क्वायर है, तो हो जाएगा 2 रो gl इंटू 5 स्क्वायर. दिस विल बी 2 रो gl इंटू 5 square. ये हो गया मेरा F2 and what was the value of F1? F1 was rho GL 5 square by 2. Are you getting my point? So F1 by F2 निकाल सकते हैं. I have told you the entire derivation now. I have told you the entire explanation how we are calculating the force, not with the formula only, with the entire derivation. Now what you need to do? You just need to find the ratio. So F1 is to F2 will obviously be equal to 1 by 4. Yes, I can see because यहाँ पे rho GL 5 square देखो cancel हो जाएगा, rho GL 5 square से बच जाएगा यहाँ के नीचे का 2 और यहाँ का 1 by 2. So 1 by 2 into 2 will be 1 by 4. And yes sir, we are absolutely correct. We have won the award. We are absolutely correct. Okay. So I suppose you all must have understood. If you are facing any doubt, any problem with this question, you can ask it right away. I'll be discussing it. And if you're not having any doubt, let's move ahead. Let's move ahead and solve this another very beautiful question asked in JEE Main 2020. And what this question says is, a hollow spherical shell at outer radius r floats just submerged under the water surface. So what does that mean? Just below the surface. So there's a surface of water and just below it a hollow spherical shell floats. Okay. The inner radius of the shell is small r. If the specific gravity of the shell material is 27 by 8 with respect to water, so what will be its density? So its density is very easy. The density of the material of which the shell has been created will be equal to 27 by 8 into 10 raised to the power kg per meter cube. Okay. So this will be the density of that spherical shell, of the material from which this spherical shell has been created. Now we need to find the value of r. We need to find the value of r, and obviously in terms of capital R. Okay sir, what we can do? So first, what has been given to us, let's just create the situation similar to it. So what the situation says is, this is the level of water and here is our spherical shell. The inner radius is r and the outer radius is capital R. Okay sir, first class. Now if it is floating over here in such a case, is position mein that ball has been floating. So the case of floating, you all know, it is at rest, it is not moving. That means the net forces acting on it is 0 and mg will obviously act. It cannot be a denying thing that mg will not act. Mg will act, and to balance mg, buoyant force will also act. So we just need to equate both of them, and in equating both of them, let's see if we come to a state wherein we can find a relation of small r and capital R. So we can do like that. Okay. So how to do that? How to do it? Just write it over here. Fb is equal to mg. Now what is the value of Fb? So Fb will be rho, that is density of the liquid. So it will be rho into volume of the submerged material. So what volume I will be considering? Will I be considering the volume of this material? No, obviously not, because the amount of volume which has been displaced will be actually the volume of this entire sphere, actually a sphere of radius capital R. Okay, and if I calculate the mass, then in that mass I will have to calculate the mass only by this region, the region which I am just shading over here. Okay, so if I am talking about buoyancy, so in buoyancy what occurs is, I am actually talking about the amount of fluid which has been displaced, that is the volume is the total volume, that is 4 by 3 pi capital R cube. So it will be 4 by 3 pi capital R cube into G. Yes, right. So this will be equal to buoyant force, and this is equal to what? So this is equal to mass into G of this material. So what is the value of mass? So for mass I will be using the density of this material into the volume of the material which has been used to create such a ball, such a hollow ball. How much amount of volume of material has been used? So this volume can be very well calculated. So we know the value of sigma, right? We need to mention the volume of the material, and this will obviously be equal to 4 by 3 pi capital R cube minus small r cube. Are you in line with me? Are you understanding? So the volume is obviously from the outer volume, छोटा volume minus करना है, अंदर के sphere का volume बाहर के sphere के volume से minus करना है, तो आपको shaded region मिल जाएगा. Simple mathematics, ठीक है. So ये expression लिख ली. Now the case is entirely depending upon your math skills. So if you are good at cancelling things, you can very well find out the answer. So 4 by 3 pi cancels, GG gets cancelled, Rho is what? Rho is 10 to the power 3. Sigma is what? 27 by 8 into 10 raised to the power 3. That 10 by 3, 10 to the power 3 will also get cancelled. So finally यहाँ पे 27 by 8 बचेगा and यहाँ पे r cube बचेगा. जल्दी फटाफट रिजल्ट निकालते हैं. तो r cube आ जाएगा ये. This will be equal to 27 by 8. Obviously यहाँ पे sigma is 27 by 8 into rho of water. So rho cancel हो जाएगा. So we need not write it again and again. और यहाँ पे वैल्यू कितनी आ जाएगी? Capital R cube minus small r cube. I'll be just telling you why this question is very beautiful. Okay. So such kind of an expression occurs. Now let's do one thing. 8 को इधर ले जाते हैं. 27 will be over here only. So 8r cube is equal to 27r cube minus 27 small r cube. Right? Perfect. एकदम perfect. Absolutely perfect. Now replace this r cube over here, 8r cube over here. So 27r cube will be obviously equivalent to 19 capital R cube, and r cube is equal to 19 by 27 times capital R cube. Okay sir. So r की वैल्यू कितनी आ रही है? r की वैल्यू आ रही है 19 to the power 1 by 3 divided by 27 to the power 1 by 3, that is 3, and r. Sir, we have found out the answer. Very good, very good. But कौन सा option है ये? Is there any option like that? Is there any option like that? No. So sir, now how to do? We were very good at using the concepts of physics. We came at a result, but the final result is 19 to the power 1 by 3. And how I can find the value of 19 to the power 1 by 3? That's very tough. That I cannot do. Even I cannot approximate it as well. So because 3's cube is 27 and 2's cube is 8. So it somewhere lies in between them. So it cannot be like okay 2.5 ka whole cube ho jayega. No, it cannot be like that. So then what to do? So just for a moment, let's use elimination of option over here. Okay, just use the concept of elimination of options over here. So if 3 are mentioned over here, the first case is 1 and the other case is 2, and that is obviously not possible because 19 to the power 1 by 3 is not obviously 1 and it's neither 2 as well. So these two options cannot occur. Sure sir. What about them? Let's create the denominator as 9 for a case and let's see, can we get closer to some fruitful result? So what I'll do is I'll actually multiply 3 over here and 3 over here. Okay, and just place this, just move this 3 inside this 1 by 3. So what will happen? I will have to suffice it with 3 to the power 3 times 1 by 3. Okay, so it will come with this result that 19 into 3 to the power 3 is 27 whole to the power 1 by 3 into r divided by 9. And what this result is turning out to be? So 27 times 19. So 27 times 20 is 540, and 540 minus 27 will be how much? 523, right? No, 540 minus 27 is 513. Okay, so this result is turning out to be 513 to the power 1 by 3 by 9 into r. Okay, now here goes your brain. Here is the usage of your brain. So your r has turned out to be this value. Okay, you used the elimination of options method and eliminated 2 of them. So 4 by 9 and 8 by 9 are left. Now it is very well clear, even I can even detect it, that 512 is what? 512 is the cube of 8 and the value over here is 513. So the answer should be near to 8. So over here 8 should arise, and even you can also use elimination of option that 4 cube is around 64. Around what? 4 cube is 64. So 64 is nowhere lying over here. So the only option left with you is 8 by 9 only. Am I clear? And what is the right answer? Yes, indeed it is. So this was actually using your brain. Okay, the physics in it was very small. The maths was also very small, but the most portion was of your brain. How well you are in approximating values, how well you are in getting to a final fruitful result. The options are like them. The options are like these only. So you will have to finally get an option out of it. And just what happened, students came at this result and were very confused that what will be the result now, because 1 by 3, 2 by 3, 0.67, 0.33, and over here also 0.7 something answer was coming. So how to get to a final result? And this was the actual approach. So I suppose you understood it, and if you are just liking this session, just like this lecture here. I'll be very delighted with the amount of likes which I'll be getting on this video. So now let's move ahead and talk about this 2019 question as well, and this one is also very important, and most of the students have done it wrong. Truly, most of the students have actually done it wrong because they cannot actually comprehend the situation which they are asking. Okay, so let me tell you about it. So a uniform cylindrical rod of length L and radius R is made from a material whose Young's modulus of elasticity equals Y. Okay, no problem. When this rod is heated by a temperature T and simultaneously subjected to a net longitudinal compression force. So because of the temperature T, it will obviously elongate, but because of the force, the compressive force, it was not made to elongate. Okay, because of this compressional force F, its length remains unchanged. Its length remains unchanged. So actually the amount of thermal stress will be equivalent to the amount of compressive stress which is getting created. Okay, so the coefficient of volume expansion of the material of the rod is, okay, they are asking the coefficient of volume expansion, but sir, we have actually studied volume expansion, but we know in the case of rod there occurs linear expansion. So you are sure about linear expansion, right? So just do the case in that pattern and finally we will see to it how we can find the result of volume expansion. Okay, so the entire case study was only this. They got confused that whenever we study the case of a rod and whenever we are also taught about it, there always is considered the coefficient of linear expansion, because the rod is supposed to expand linearly along its length. But over here they are asking about volume expansion. So what the case is? So let me tell you. So first let us just draw what the case is. So what is happening is that here's a rod and obviously it is getting heated by a temperature T, and because of this temperature T there will be an elongation, and obviously the elongation will be how much? So it will be delta L naught will be equal to L naught into alpha into delta T. Okay. So the elongation will be depending upon the original length into alpha into delta T, and delta L naught by L naught will be how much? So delta L naught by L naught will obviously be equal to alpha delta T, and this is the strain, developed. So this strain multiplied by Y, will actually give you the value of thermal stress which is getting developed. So this is what? Y times strain is stress. So this is the thermal stress. Okay, this is the value of thermal stress and it is equal to alpha Y, and delta T is also given to us here. They have been given to us that the amount of increment in the value of temperature is T. So replace delta T by T. So this is the value of thermal stress. Okay, now this is not the case. Actually it is getting compressed. Okay, it is getting compressed by some machine or so. So it is getting compressed by the same amount of thermal stress, and this is the only possibility, and then only we can claim that the length hasn't changed. So the amount of thermal stress getting developed should be balanced by the compressive stress created. So this will be equal to the compressive stress, and the compressive stress is, they have given the value of compressional force. They also have given us the value of area as well, right? To a net longitudinal compressive force, F, its length remains unchanged. Okay. So they have obviously given us the value of area as well. They have given us the value of rod. Yeah, the radius has been given. So we can very well calculate the area. Obviously it's a rod, so it will be a cylindrical structure, right? And the forces will be exerted on these ends. So the area over here will be pi r square. So this will instead be equal to F upon pi r square. Am I correct? Yes sir, you are absolutely correct. So from this result, can you find the value of alpha? We can very well do that. So alpha will turn out to be F upon pi r square into yt. F upon pi r square into y into t. And here we are, we have found the result. So this is the coefficient of linear expansion now. This is the coefficient of linear expansion. But what they are asking is, they are asking about the coefficient of volumetric expansion. Now, do you people have ever related the coefficients of volumetric expansion, superficial expansion and linear expansion? You very well know the result. The result is that alpha is equal to beta by 2 and that's equal to gamma by 3. Where beta is actually the coefficient of superficial expansion, gamma is actually the coefficient of volumetric expansion. So you know the value of alpha. You can very well find the coefficient of volumetric and superficial expansion both. And what we need to find over here? We need to find this value of gamma. So gamma is what? Gamma is 3 times alpha. So just multiply 3 over here, so it will be 3f upon pi r square into y into t. Okay, and this is the final result. Okay, so are we correct? Let's check it up. Are we correct or not? Yes sir, you are absolutely correct. We are absolutely correct, and this is the explanation. Okay, so if you are facing any doubt, any problem till now, you can just comment and you can ask any doubt regarding this topic of mechanical properties of solids and liquids. Okay, meanwhile let's move ahead and solve another question, and this question you can also solve it because the formula I have already told. I have told you the formula, and this question is all about that only. The structure, the curved structure which is created on the rotation of a cylinder or of any container. So the question is entirely about that only. A long cylindrical vessel is half filled with a liquid. When the vessel is rotated about its own vertical axis, the liquid rises up near the walls. The same case is happening. So it is being rotated about this, and the entire structure now moves like this. Okay. So the radius of the vessel is 5 centimeter and its rotational speed is 2 rotations per second. Then the difference in the heights between the center and the sides, very simple. So you again have to use this relation of y is equal to omega square x square by 2g, and you can very well find the result. Okay, so this will be a homework for you people, and now let's move ahead and talk about this question. Okay, so a solid sphere of radius capital R acquires a terminal velocity Vt. Okay, sorry, not Vt, it's V1. So this is a solid sphere and it is of obviously radius capital R, and it acquires terminal velocity. Okay, due to gravity through a viscous fluid having coefficient of viscosity eta. Nice. The sphere is now broken down into 27 identical parts, and now if each of these spheres acquires a terminal velocity V2, when falling through the same fluid, the ratio of V1 is to Vt equals to. So in this question, what you actually needed to do was, you just had to remember the relation how velocity is changing with radius. And if you would have remembered that the terminal velocity was actually changing with radius to its power 2, you would have very well calculated the result. Okay, and the same case applies over here. The terminal velocity is actually depending upon r square, whatever is the radius of the sphere which I am talking about. Okay, so now we can very well calculate V1 is to V2. Yeah, it will be equal to what is the velocity V1? It is of the bigger fluid of radius capital R, and V2 is the terminal velocity of smaller solid spheres which are of radius obviously small r. Okay, so it will be capital R square upon small r square. Now what we need to do, we just need to relate this small r and capital R, and that I can actually do. So on breaking them into 27 identical parts, their volume will obviously remain same. So the volume of the bigger solid 4 by 3 pi capital R cube will be equal to 27 into 4 by 3 pi small r cube, right? Yes sir, perfectly. 4 by 3 pi gets cancelled. R will be equal to, take cube root both sides, it will be equal to 3 small r. So this small r can be replaced by r by 3 whole square. 9 will go upstairs, so it will be instead equal to r square upon r by 3 whole square. R gets cancelled, so 3 square will be equal to 9. So V1 is to V2 is coming out to be 9 is to 1. And is this the answer? Yes, it is the answer. We found it very easily. We just had to remember, or we just need to know that velocity, terminal velocity is the representation is 2 by 9 times sigma minus rho and r square eta and a into v, the somewhat relation will be like that, but we just need to memorize the fact that terminal velocity was actually changing with radius to the power 2. Okay, so this is the answer, and this will be now the end of the session. And if you love the session and you had a good experience with all these previous year questions, if you want to practice more, so where you need to do, you just need to go down and check the link for Extramarks learning app in the description. Okay, and you can download the app. You can practice unlimited amount of questions. Obviously there is no limit to the amount of questions you can actually practice, and the questions are not randomly distributed, they are properly segmented. So based on some filters of subject, class, level, you can practice as many questions as you want. Even you can avail the benefits of giving test as well. You should give test. It's my personal recommendation to each and everyone, the aspirants who are here, who are watching this episode. You should definitely give test. Without giving test, I am sure cracking any of the exam is very impossible. There are very few students who might have told you that I haven't practiced a test and I have secured a rank. That's very rare. Obviously, practicing a test is very important, because when we practice at home, the questions, whenever we practice, there is no limit or there is no time frame in which we are practicing. And the questions, the level of questions which I have practiced today, you must have very well noticed that they were calculative in nature, and we actually had to use our brains. So on those 3 hours when things are not obviously under our control, so using our brain in a very peaceful manner becomes very rare. So you need to get a glimpse of what you are about to feel on that final day when you are about to give the exam. So for that reason only, giving test in a very proper manner, in a span of 3 hours, in a span of 1 hour, just competing with yourself only, that okay, today in 1 hour I was able to practice 10 questions, the next day I will be practicing 15, the next day I will be just increasing it to 16, 17, 18 and 20. Okay, so do give yourself a competition only. Okay, and based on these tests you will get a rank, and this rank can actually obviously tell you where you are actually presented, and your present location is how much, in which rank you are. Obviously there is a report as well generated which will actually give you a very good highlight about which all topics you face difficulty, in which questions you actually face so much amount of time, and what all topics you actually have to stress upon to improve your existing knowledge. So this will all be about our app, and our next session will obviously about thermal properties of solids and liquids. Remember the date, it is 7th of Feb, and sharp 3 p.m. we will be meeting again and discussing the previous year quality questions of thermal properties of matter. Okay, so this will be all from this side. Thank you. We will be meeting in the next lecture. Bye bye.